Now we're recording to my computer. Okay, here we go. Let's do this. Miss Coleman, might you introduce yourself to us? We have a guest.
I'm Miss Coleman. I am a math teacher at Blair as well. I teach Algebra 1 and Intro to Stat, at least this year.
Do you do anything else at Blair besides math?
Oh yeah, NHS. Some of you guys might know me through NHS.
Ooh, that's true.
I am the NHS sponsor, even though our officers do most of the work.
For the people that don't know what NHS is, can you explain that real quick?
So NHS is National Honor Society, and it is just an honor society for students that have outstanding GPAs, are committed to service, and have shown like excellent in leadership. And then this year it's been kind of weird with online stuff, but we try to do service projects for the school and for the community. So trying to figure out how to virtually serve the community has definitely been a challenge this year.
So I was in NHS in high school. I don't know if I met any of those requirements though.
You probably did.
I mean, I might have. I mean, I got in, so I think I checked the boxes, but I wasn't the most stellar student.
But NHS does like a creepy like candle lighting induction thing, right?
That's a secret.
Oh, sorry, my bad.
Well, I'll edit that one out. All right, we have an icebreaker question for you, and it is: what is your favorite pizza topping?
Oh, just one?
You can have if you were to order a pizza, what toppings would you get on top? But also, like you can consider like how toppings increase the price, whatever you want.
I've got my answer.
Okay, sorry. Whoa.
Margarita pizza is the best type of pizza. So tomato, mozzarella, and basil, like lots of basil. And if you have like fresh tomato, mozzarella, and basil, that's like an outstanding pizza. And then you also have to put like spices on it.
Mm-hmm. Mine's always been pepperoni when we ask the question. Just boom.
You're wrong, but
I mean, everyone has their opinion. Some are right, some are wrong. All right. Do we have any other questions? Do you have any words of wisdom for our 9th graders and our 10th graders here? And a few 8th graders.
Words of wisdom.
Like Miss Sanchez said, check the bag. That's her word.
I had the same reaction. What?
But it makes so much sense.
It makes so much sense the more you think about it.
I can't think of any words of wisdom. I guess mine aren't, it's not as pretty sounding as just check the bag. Don't overthink it, just do it.
Don't overthink it. I like that's apropos for your answer. Don't spend 25 minutes thinking about what words of wisdom do you have. Just don't overthink it. No, I like that. That's good.
Pretty meta.
But
that's meta. That's
I am a textbook overthinker, so I always overthink things. So that's my advice, is what I try to do is not overthink it as I overthink things.
Awesome. All right, so we're going to get started with this math video. Stick around for a little bit, but if you have to head out, head out. I'm going to go ahead and share my screen. We are doing, that's you guys. We are doing side angle, triangles, and area. So in the last video, just from Ms. Coleman, we talked about the law of sines and the law of cosines, solving triangles, finding the 3 sides and 3 angles of a given triangle. The problem is, if I give you, well, let me backtrack. If I give you 3 sides, there is a unique triangle with one exception. If 2 of the sides don't sum to the 3rd side, that triangle can't happen. That actually happened to us in the last video. We had a side 10, 12, and 25. You can't construct that triangle. But you got side, side, side. You got side, angle, side. If you have a side, an interior angle, and then another side, you have a unique triangle. There's a bunch of patterns: side, 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 angle, side, angle, side, angle, 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 side, HL, and I think I'm missing one. Angle, side, angle. I don't know. Doesn't matter. There's this 6th scenario: side, side, angle. And it does not guarantee a unique triangle. If I give you two sides and an exterior angle to those two sides, it does not guarantee a unique triangle. It might, but it doesn't guarantee it. And our job here is to look at all the different scenarios, and then if given side-side angle, if given two sides and an angle, which you guys will get later, those are the answers, don't look. If you're given an angle and two sides that are outside that angle, solve the triangle. And if there are more than one possibility, solve for all the possibilities. And if there's no possibilities, that's the best scenario because that means no work. All right, so you have been crabbed already. All right, so let's go ahead and get started. Your job to Mrs. Contreras and Mrs. Coleman is to figure out the 6 different scenarios. I know them. I am the gatekeeper. I will provide a little bit of like a nudge in a certain direction. Whenever I look for the 6 different scenarios, I draw my my triangle in a very specific way. So you're given a side. Ooh, let me fix my drawing pad. You're given. Oh, nice, nice. So you're given a side. Let me break out the line tool. Where is it? There it is. You're given a side. Another side. So this angle right here that I've drawn, that's variable. We can change that angle. So you're given a side, another side, and you're given an, I think I'm messing something up. Side, angle. You're given, let me make sure I got this right. I'm doing it completely wrong. So sorry. Let me backtrack. You're given a side. We don't know how long this side is. We're not given that side. So we're given side, we're given an angle, and we're given another side. This is the angle that's variable. So sorry for being a little bit confusing here at the beginning. So we need to figure out, when does this triangle exist? This side right here cannot be changed. This angle cannot be changed, and this side right here cannot be changed. Everything else is variable.
So the way you've drawn that, it looks like we're not going to get a triangle from this case, because I guess either our angle is too big or our side length our second side is too short.
Yeah, so let's like give ourselves some letters. Let's give this A, let's give this B. What would this angle be, Mrs. Contreras?
That would be angle B, capital B, because it's across from our side B.
Mm-hmm. So kind of tell me what we got going on here. Tell me something about angle B.
Angle B looks like it's acute.
Yeah, so let's go ahead and write that down, acute. So that's a scenario that can appear. We're given, the angle that we're given is acute. Okay. What's the relationship between A and B?
Oh, A is longer than B. So that means that angle A is going to be greater than angle B.
Okay. So we're kind of, I've drawn one scenario. There's 6, and we're going to start to change things. But with the scenario we're given, we have an acute angle, and the side opposite the angle we're given is smaller than the side that we are given. B looks pretty small, right?
B does look pretty small.
How big would it need to be so that we get to this dotted line?
It would need to be, let's see, so we would want, maybe we can drop a line here to figure that out. Would that help?
Guessing based on your language that you're dropping it?
Use some
Shabam.
trig, right?
Do you know what that, does anyone here know what that thing that we just dropped is called in a triangle?
Perpendicular.
Perpendicular is a word. The one I was looking for was altitude. The altitude of a triangle. The perpendicular distance between a vertice of a triangle and its opposite side. Okay, so what is the length of that altitude? We actually have the information to find that length. Given an angle B, a side A, and a side B, we have the information. We have the numbers to establish what that magenta length is.
Magenta. All right.
I think it's
So-
more maroon, but
Can we call this altitude H because we already have an A?
Mhm.
And then could we think perhaps like sine of B is going to be H over A? Does that advance our cos at all?
I think so. Yes, it does. Right, so what is H?
H is going to be the altitude, but then it's also shared with this other triangle that we have on this other side. Is that?
Well, I guess you have a formula. Sine B is equal to H over A. What I was kind of asking you to do is solve for H.
Oh, solve for H.
Yeah. So like, what is the numerical value of H?
H is equal to A times sine of B.
Oh,
H is equal to A times sine of B. All right, so we're about to get 3 of the 6 scenarios. We have chosen the scenario that has the most variability. I'm gonna give it a name in a second. But when B is acute and B, when angle B is acute and side B is less than A, when do we have 0 triangles?
can you ask that question in a slightly different way?
Yeah, I can. So forget this scenario here. If I give you an angle B that is acute and 2 numbers where the one opposite angle B is less than angle A, 3 things can happen. Or 3 of our 6 scenarios can happen. Right? We are not right now constrained to this really small B. We can vary the size of B is kind of what I'm getting at. All we know is that B is less than A. There are 3 things that can happen. When or I'm trying to rephrase this question so that I can help. How about this? If B is less than A sine B, if lowercase b is less than A sine B, can we construct a triangle?
No.
Right, that B is going to be too small. We're not going to get to this dotted line that is cemented in. If B is
Because B is shorter than our altitude that we're
Mhm.
dropping. Right? So then we
No.
have, it's like too far up. It's going to be like the end of a crane or something.
So now we're kind of getting into the groove. Do you know where I'm going to go with this?
Nope.
All right. So what if B is equal to A sine B? If B is equal to A sine B, it is still smaller than A.
Yes, that's true.
That's kind of what I'm getting at here.
Okay.
There's
Then we
3
have a right
different-
triangle.
We have a right triangle. So how many triangles do we have if there's a right triangle? Just one. Ms. Coleman coming in with the answer. There is one triangle, and we have a unique triangle. So to any teacher in the past that told you that side sine angle does not create a unique triangle, that's kind of, it's not incorrect to say it, but it's kind of, it's missing information. There are unique triangles in SSA. If we make a right triangle, it's actually the HL scenario that I referenced in the last video.
Because
there's
you
one-
know that you have a right triangle, so you can say you have a hypotenuse.
Then there's one last scenario, and that is B is still acute. Angle B is still acute. Side B is still less than A, but it is larger than A sine B. How many triangles can we have at that point?
Because that would mean that we're making a triangle like,
I've just extended the B up in the picture.
oh, okay,
Oh, who just dropped that purple segment?
that was me.
That was you? I don't know if Miss Coleman's in the doc or not.
No, you know she's not because she's not in the bottom. doc.
True.
Then it would be HC, right?
Yeah, to any students that don't know if you're in the doc or not, I can tell with the initials at the bottom right. There's no getting past me. That's totally not true. Anyways, how many triangles can we make?
Well, it looks like we made 2.
We can make
You have
two.
one going this way and one going this way.
Two triangles. Oh, I've switched to blue. That's kind of unfortunate. I call this the swingy one. Swingy is a. Is that how you spell swingy? 1G?
I really don't know.
It doesn't matter. All right, because those two triangles happen from that B side swinging, and that B side's allowed to swing. Because the angle between side A and side B is unknown. We don't have that piece of information. Right? This is the worst scenario. The reason why is because in a American math classroom, they ask you to numerically calculate things all the time. And if you're given this scenario, there's lots of things to calculate. Because if I say solve this triangle, you have now 12 numbers to find. This is not 12, this is 10, but 12 numbers to find. I don't like this scenario. I really like this one. If I give you a side angle and B is less than a sine angle B, like you're in business, you're done.
Wait, so you would rather have no answers than 12 different
In terms of like, how much work do I have to do? Scenario one is the best. In terms of like usefulness, probably scenario two is the best.
Right?
And in terms of I like to do math and practice, scenario three is pretty good. They all have their pros.
Yeah.
And I guess they have their cons too. No triangle is kind of useless for, actually building things and stuff.
Mm-hmm.
All right, we have 3 of the 6. Where do you think? Well, actually, there's one more in this acute angle scenario. B is acute. What might that 4th scenario be when B is acute?
So B could be longer than A.
Yeah, if B is longer than A. Now remember, B and A, given angle B, that tells us where side B and side A are. B is across from angle B. So we're given some side we don't know. We're given an angle that's acute. We're given some side. And then the side opposite angle B is now longer than A. How many triangles do we have here?
Is this a trick or is this just one?
It's just one, right?
Oh.
Can we swingy?
No.
We can't. We can't swingy like we have the altitude here. If we swing in, this side ends up, I guess, like over here, but then that's no longer the triangle.
We're not using angle B anymore.
Yeah. So there's only one. So if B is acute and the side opposite B is larger than the other side you're given, then there's one triangle. Okay. So there are several scenarios, currently more than not, that have unique triangles. Side angle has unique scenarios. All right. Where do you think the last 2 come from?
B is not acute.
Yeah,
so I guess what are those options? Right and obtuse?
Let's look at obtuse. I think if B is right, I wonder what happened if B is right. Let's draw obtuse. I think the same scenario happens. So we have an obtuse angle. We have some side that's variable. We have an angle though that's obtuse. And this is going to be B, and this is going to be A. And then now let's think about what the other side B could be. No pun intended.
Well, it needs to be longer, right? Because we have an obtuse angle. So B has to be longer than A in order to give us a triangle at all.
Mm-hmm. So if B is longer than A, then we're able to get to that dotted line. And we have one triangle, right?
Yep.
There's no swinging happening here. And then the other scenario is what you're saying. If B is less than A, we have an obtuse angle. And I think this works for right as well. We can think about that if we want. But if B is less than A, we're not going to get to that third side. So 0 triangles. Let's see if I missed any. Side angle. Recall that side angle is not a valid theorem in geometry. It's because if you're given two sides on a non-included angle, it is not guaranteed that a unique triangle exists. However, there are three possibilities. No triangle exists, exactly one, or two. Suppose that you know sides A, B, and the measure of angle A. So we just did it with B, but I mean, letters are variable. If it's obtuse, and oh, look at that, A is less than or equal to B. If it's equal to, I think we get that right triangle scenario, maybe not. No solution. If A is bigger than B, one solution. And if we have an acute angle, we get these four solutions. No solution if it's not long enough. But you didn't grab me because it appeared on the screen. Does that count?
Yes.
We have the right triangle scenario, the swingy scenario, and then the one solution scenario. You know, both. This one says greater than or equal to 90. So I think that right angle idea you had falls into this first scenario.
But that makes sense, right? Because if you have something that's perpendicular, right, and then you have like something here that you're trying to move, the connection, yeah. Makes sense.
Cool. All right, let's do a few examples and then potentially call it a day. When we get to that area page, Mrs. Contreras and Ms. Coleman, maybe we will push it off to another time.
Or leave it as an exercise for the viewer.
Leave it as an exercise for the viewer. I like that. All right, and still give practice problems on area. All right. So let's see. Can you just tell what we have from the given numbers?
So we have an obtuse angle, right?
Okay.
A is greater than B.
A is greater than B. What do you think? In a second, I'm going to draw a picture because Ms. Coleman?
It's going to be one unique triangle.
One unique triangle. So we got one.
A and B's are flippy-floppy from what we had before.
A and B are flippy-floppy from what we had before. Right. For me, I'm a visual person. I get that there are formulas and people love the formulas and people even commit that to memory. I like to draw a little picture. It's always the same picture. And then it just tells me. I draw my little dotted line. I have an obtuse angle. It doesn't really matter that you draw your angle perfectly accurate, but it's obtuse. So I'm going to give myself an obtuse angle. That's A. B is the one next to A. That's 46 units. And then A is obtuse. We are exactly what Ms. Coleman said. One unique triangle obtuse. And then we need to solve. And that's the law of sines and the law of cosines. Do you think we need to actually solve it here? What do you think?
No, I don't think so.
Let's not. Let's just like work through different scenarios and call it a day. Let's not kill too much time here. Right? One obtuse. What would actually, before we move on, we're not going to completely solve it, but would you use the law of sines or the law of cosines here?
I would probably want to use the law of cosines because we have an obtuse angle, so it just kind of like avoids the danger that we had from sine.
Can you explain the danger that you're talking about to Ms. Coleman?
So it's dangerous to deal with obtuse angles when you're looking with sine, because arc sine's range domain is lovely picture, is going from negative pi over 2 to pi over 2, or negative 90 to positive 90 degrees.
So if you use if we had an obtuse angle and you used arc sine on it, what would you get?
You would get an answer that's within negative 90 to positive 90, which is not necessarily helpful if you're looking for something that's greater than 90. So you need to do a little bit more, math in order to get the answer that you're looking for.
Conveniently, it ends up being the supplement, but just the best bet whenever solving a triangle, go for the acute angle. And then find the obtuse angle last. So I agree. I'd use the law of sines here because it doesn't matter. We have the obtuse angle. And we have a pair of sides, angle A and side A. All right, scenario B. 41 degrees, 2 and 7.
Should we draw our picture?
You can draw a picture. Well, I kind of want to do like a Jeopardy thing, like a ding. Who thinks they know it first?
Oh, I see.
That's what we're going to do for the next 3, by the way. I've decided right now. Wait, what did you say, Miss Coleman?
There's no triangle.
No triangle? The problem is I don't know the answer, so I can't like say wrong and then go to Mrs. Contreras. Okay.
But
Acute. We're given a 7. Okay, so this one requires a little bit more work. This is 2. You're saying no triangle, Mrs. Coleman. Why are you saying that?
Oh, that's true.
Right? This is B.
Jumped the gun.
No, did you say 1 or none?
I said I jumped the gun. Like I rushed it. I didn't do the math.
Well, to be fair, I completely agree with you. There's no way that 2 is getting to that side. 41, that's close to 45. There's like a good angle there. If it was like 1 degree, then yeah, I think that'd be 2. But you're solving for something. What are you solving for?
You're
I
comparing
thought
2 to 7 sine of 41.
Are you getting it?
Yeah, it's. Wait, hold on. I haven't used degrees versus radians later.
I was actually super hoping that would happen to you.
Double check.
You just got to double check. You know, I always double check, even though when I know I'm in the right mode.
I do too when I'm on tests or like when I'm doing tests and things. But
I think that's a symptom of being a teacher.
well, you're geometry and pre-calc right now.
Yeah.
Statistics and algebra, so I haven't had to check with my angles in a while. 0.59.
0.59. Wait, that feels
For sine
0.59.
41.
Oh, sine 41 is 0.59.
4.59.
4.59. Sweet. Can you give us 3 decimal places? We have a rule where we go to 3 just because of AP tests.
4.4592.
Nice. Thank you. And 2 is not going to get you there. If this is 4, let me do a dotted line. If this is 4.5, 2 is not going to get you there. All right, we're not going to do any more of this problem. Well, actually, we finished the problem. Never mind. No triangles. So I'm saying I love it when there's no triangles because you're just done. But that's just the lazy in me. All right, a Jeopardy style. 36 degrees, 17 and 16. Got some C's going on.
That doesn't matter, right?
No.
Like C
Letters.
versus B.
No, it doesn't.
2.
You have to go ding. What is 2?
What is triangles?
All right. Miss Coleman has a fast brain. That's all I'm saying.
Yep.
We got an acute angle. That's C. 17 is the one next to it. Remember, C and C are opposite each other. And then 16, it's pretty big. I have a pretty strong feeling that is going to be bigger than, what would it be? A sine C? I don't know what A sine C is. 17 sine 36. Is anyone calculating it?
Yeah, it's 9.992.
Yeah. 9.992. Yeah, that's super far.
And if
Yep.
if those of you are too lazy to get out a calculator and you're running this on MATLAB, then I'll drop a comment with the MATLAB that you can use.
Ooh.
Because I am too lazy to remember what the trig stuff is with MATLAB for degrees versus radians. So I just convert to radians.
By multiplying by 180 over pi or whatever.
Yep.
Love it. All right, so we have one really tiny sliver of a triangle. And then we have one like, I don't know, very large area triangle, I guess. One like almost, what would that be called? It's a almost equilateral
line.
triangle. Yeah. All right, one last one. 30 degrees, 10 and 14.
Oh, 30 is nice. We know that.
30 is nice. Yeah. Sine of 30 is
Ding.
1/2.
What is
We could do this one in our
one?
brains. What is 1? I'm really glad that you like progressed from like knowing how to play Jeopardy to from not knowing how to play it to playing it. Okay. 30 degrees. We can actually figure out these things without a calculator potentially. 30. That is side C. We have a 10 here. We have a 14 here. So that we don't even need to do a B sine C or whatever it is. A sine C. Yeah. Because that is a single triangle. One triangle. And then you'd proceed to solve it, which we're not doing here because that's just a lot of calculation, quite boring.
But you all should pause the video now and do it.
Yeah. I'll throw in the questions. What is, side B of this triangle? Okay, should we do this or not?
We should talk through it at least.
Yeah, let's talk through it. All right, so finding the area of a triangle, something everyone did in geometry, very like massive topic in geometry, area. But we want to use trig because that's kind of been the theme for like almost all of semester 2. So find the area of triangle ABC. This actually won't take very long.
Base times height?
Yeah, so
1/2 base times height.
1/2 base times height. Let's get the area of a triangle. 1/2 base times height. Base and height are completely arbitrary in terms of the side you choose. Just drop an altitude. You got your height. So go from the side opposite your base. Here, I would probably choose B down to AC. I believe it's also like the sides that were given. It's going to be nice. Given that now our base is AC, let's fill this in. What is the base?
AC.
And how long is it?
Oh, 11.4.
11.4. And actually, conveniently, we've already talked about this. What is the height of this triangle?
That's sine of 33 degrees times 12.2.
Yeah, we've been doing this a bunch already in this, so that kind of saves us some trouble. And then I guess we're going to get some answer.
Yep.
I'm going to bash it out as fast. Ready, set, go. I'm going to win.
Are we like racing?
That's,
racing isn't necessarily helpful. Fast does not equal intelligent.
But it does mean a shorter video.
That's what double speed is for.
I'm also like struggling. So
I got 37.874.
I'm going to say units squared because we're not given units.
Okay.
Sweet. All right, so what would this be in general? Finding the area of a triangle using sine. Here's our height.
We would have, right, the height. So we have 1/2 base times height. And the height we can substitute with, what is that? C times sine of it.
In this case, yes, C sine A. We could do A sine C. We could do a bunch of different things, but C sine A. And then our base here is B. That's convenient.
That is convenient.
Yeah.
It's almost intentional.
I don't think it was though. I think it's just A, B, and C. B's on the bottom. All right,
and it's
that
nice.
is our.
This is nice, actually. I like how we have this written because it shows that we still need some information from every aspect of our triangle.
Which like totally makes sense, right?
Yeah, because we need 3 things to define our triangle unless we're doing HL. But then we implicitly also know an angle.
So if you're given side angle side, you got all the information you need. If you're given a side, another side, and the inclusive angle, you got BC. Okay. This is the length of one side, the length of another side, and then the angle between them. If you're given side angle or angle side or side side, you're gonna have to do a little bit of work to get an angle, but then you're home free. There's actually one last formula that's not on this document that I want to just shout out and throw out there. And I'm going to link in the description a a link to a video I made last year on something called Heron's formula. Heron was, I think it was Hero of Alexandria, some like Greek person from a long time ago, formula. They came up with this formula. It's kind of cool. So there's this number S that is the semi-perimeter. That's just 1/2 A plus B plus C, half the perimeter. There's a formula that says the area of a triangle is equal to the square root of S times three things. Is the semi-perimeter larger or smaller than any given side? There is an answer to this question.
It would be larger, right?
It must be larger, right?
Because you're taking three things, adding them together, but just dividing by 2.
Well, so
Adding
what
like
if I
half.
have 50 plus 1 plus 1 divided by 2,
That's 52 divided by 2.
which is 26?
So then the 50
is bigger
is
than the
bigger than
26, right?
26.
What's wrong with what I've drawn here, though? What's
Like
wrong with my
51,
example?
1 is not going to give you a triangle.
What
gonna be-
rule is in every triangle? Think about side, side, side. Every triangle satisfies this rule.
2 of your sides added together can't be more than the other one.
Yeah, so given the 3 sides that I choose, the triangle inequality must be true. 2 of the sides always must add up to the 3rd side. With that piece of information, the semi-perimeter is always going to be larger than any given side. So that's how I know to put the S first. That is the formula for an area of a triangle. It's called
Whoa.
Heron's formula. The square root of the semi-perimeter times the difference between the semi-perimeter and each side. And the proof is very algebraic. It takes an entire page and probably 20 minutes. So didn't want to do it in this video, but I'll link to a time when I did it in the past, so that people that do want to see a derivation of that, they can.
Be sure to like and subscribe.
Don't forget to like and
Hit that bell.
hit that bell, smash the like and subscribe button. Boom. All right, there it is. The most annoying case of the law of sines and cosines, side angle. Annoying because it's a little bit extra work you got to do. Let me stop my share so we can see all of us on the big screen. Miss Coleman, thank you for sticking around. We really do appreciate it. We've been talking independently about getting you on this, and then you showing up like made that happen. We're very happy. Mrs. Contreras, do you have any words of wisdom?
Do I have any words of wisdom?
I ask this to Mrs. Contreras every single time, Miss Coleman.
That's
So
true.
think about how annoying that might be.
No, it's fun because then you just pull a random nugget out of your brain.
Yeah.
Well, I think carry a water bottle is like very helpful because like we've talked about drink water, but like practically speaking, carry a water bottle and then you can drink water more. It's great.
If you, I'm gonna turn my screen, and if you look really careful, let me like get it right. The corner of my screen, you'll see something. Do you see it right there?
The projector.
Right next to the projector. It's kind of hard to see.
It looks very washed out.
I wonder if I can, let me do something real quick. This is a dangerous move. I'm unplugging some stuff.
Oh my gosh. Motion sickness warning. Why do you have a disco ball?
Can you hear me?
Yes.
Because my words of wisdom is always make some time to take a break and dance.
And dance.
Oh my goodness.
Back when I used to work at the music center at the University of Maryland, we would have random dance parties in the office. We would just, everyone would stop what they're doing and then just break out into dance. Someone would play music on their computer. And It's been hanging there for 2 years. Every year I ask my class, what is one thing that you want to decorate this room with? And 2 years ago, they said, let's get a disco ball. So we got a disco ball here. So my words of wisdom are always take a moment to stop and dance. Should we end it like that?
For a moment there, I thought you were going to actually stop and dance, and that's why you were turning the computer around.
Maybe we should just dance and then can cut it off in the middle of our dancing.
Boots and cats. Oh, I don't want to play any music because then we'll get a copyright strike. Boots and cats, boots and- I'm trying. I unplugged everything so I can use my trackpad.